So we were talking about a relation, and we're going to talk about certain properties of relation as well as a special type of relation. That's the next step I want to talk about. So the domain of a relation represents all the first values or words in the relation. Okay. So the domain represents the first set of elements. Whether they be words or numbers or letters or whatever. And the range represents the second set of elements. You are going to be using domain and range quite a bit for the rest of this year, as well as in grade 11 and 12. So you will know it thoroughly. Okay. A function is a type of relation where every domain element has exactly one corresponding range element. What that means, and this is probably a better way for you to remember it, domain elements never repeat. They don't appear more than once. Okay? So let's look at the following relations. Relation 1, it associates the last 4 months of the year with the number of days in that month. So if I wrote it as a set of ordered pairs, what would my first pair be? The last 4 months associated with the number of days in that month. What would my first pair be? What are the last 4 months? So September, and how many days? 30. What would the next pair be? October, 31. Next, November, 30. And finally, December, 31. Okay. So there's 4 pairs in that set, in this relation. Okay. Now, is this relation a function? Does every domain element just have one range? Do you see a domain element that repeats itself, that occurs twice? Domain, not range. No. The range elements repeat, but that doesn't matter. It's the domain. So we can say yes because no domain element repeats. Now, what if we wrote this relation the other way? Okay? The number of days in a month with the last 4 months of the year. Remember, order matters. So in this relation, the 4 ordered pairs would look like this. They would be reversed. 30 September, 31 October, 30 November, and 31 December. Is this one a function? No. Because domain elements, or in this case numbers, domain elements repeat. Both 30 and 31 repeat. So hopefully you get the idea of how to identify the domain, how to identify the range, and whether it's a function or not, and why. So let's look at a couple more examples. So we've got 2 relations here in A and B. We're asked to, one is given as a set of ordered pairs. The other is given as an arrow diagram. So you're asked to do 2 things: identify the domain and range of each, and state whether it's a function and why. So when we list the domain and range, you can just put D. We have to list them in braces. Proper notation. And then really all you're doing is you're just listing all the first elements. So for the domain, it would be a right triangle, an acute triangle, square, rectangle, and regular hexagon. That's it. For the range, you'd list all the second elements. And you don't have to list twice if it occurs twice. So for this one, well, the second element in the first pair is 1, and the next one is 0. The next one is 4. The next one is 4 again, which I've already written, so I don't have to write it twice. And the last one is 0, which I've already written, so I don't have to write it twice. So I only have to list 3. Okay. Function or no? Look at the domain values. Look at the domain. Do you see one that occurs? Remember, don't look at the range, the domain. Do you see a domain element that occurs more than once? No. So it's a function. Domain elements don't repeat. That's the reasoning. Okay. So the next one, the domain and range are going to be all numbers, which is what we're going to get to. Okay. So in an arrow diagram, the domain will all be all the values in the first oval. and the range will be the second. So what would the domain be in braces? 149. That's it. And then the range, you just have to write the numbers. -3, -2, -1, 1, 2. Okay, so you got to look at this carefully. Is this a function? Look at the domain values. Why not? Because 1 is used twice, because it comes out twice. So is 4. Right. So, not a function. Because domain elements repeat. Okay. Another property of relations and functions that we can talk about, and perhaps you've already seen this in science, is independent and dependent variables. Okay? Basically, in math, the domain is the independent variable. Okay? The range is the dependent. So in a table like this, okay, this would be our independent, and this would be our dependent. These would be all the domain values. These would be all the range values. Okay. So when you have, remember we can represent relations and functions now in different ways. So when we have ordered pairs, so for example, I'll just put 1, 2, 3, 4, 5, 6. Okay. Those represent the independent variable and the domain values. Independent variable. Domain values. Second ones represent the dependent variable and the range values. We've already seen a table up here. First column represents the independent variable and all the domain values. Second column represents the dependent variable and all the range values. If we have an arrow diagram, so I'll just do the same ones. 1, 3, 5, 2, 4, 6. First oval represents the independent variable and then the domain values. Second oval represents the dependent variable, the range values. And finally, because we've seen it a couple of times, if you have a graph, the horizontal axis will always be the independent variable. And the vertical axis will be the dependent variable. That's how they'll always go. Okay? Whether it's a table, ordered pairs, arrow diagram, or a graph. So independent variable goes with the domain, dependent variable goes with the range. Okay. This is the last one I want to do. So we've got a relation. Okay, they're all relations, any of which we can say further are functions. Why is this one also a function? One sentence explains it. What? Yeah, domain values don't repeat. And I can put values instead of elements because they're numbers. It's the independent variable. Number of marbles. What's the dependent variable? Mass. And finally, write the domain and range. Remember, braces. So you just write all the values in the independent variable column for the domain. So 1, 2, 3, 4, 5, 6. And then you write all the corresponding masses from the dependent variable column. So we get 1.27, 2.54, 3.81, 5.08, 6.35, and 7.62. Okay. So just a little bit further with relations, we talked about a couple of properties, domain and range. We talked about special type of relation called the function, and then how we can call all the domain elements represents the independent variable and the range elements represent the dependent variable. Okay, that's all I want to cover for today. We'll start getting into a little bit more mathematical